children, greetings all. Today I am teaching you upthrust and the Archimedes Principle. What is upthrust? You must have experienced if an object is immersed in a liquid, then a force acts on the object by the liquid in the upward direction, and this force is known as upthrust or buoyant force. If suppose you bring a can and then you close the mouth of the can by a airtight stopper, then put the can in liquid, what do you find? Initially you will see that the can is floating on the surface of the liquid or water. Now you apply the force to make it sink. So at that moment, whenever you are applying the force on the can to make it sink, means you are pushing the can in the water. So during that time you feel one upward force by the liquid on your hand, and this upward force which is acting which is acting on your hand by the liquid is known as upthrust or buoyant force. And let me write down the definition of upthrust or buoyant force. Please note it down. The force, the upward force exerted on a body when it submerged in a liquid is called upthrust. So the upward force which is exerted on the body by the liquid is known as the upthrust. Remember that the upthrust always acts in the upward direction. Can you say me what is the condition for a floating body, or what is the condition for a sinking body? Means in which condition the body will be sinking and in which condition the body will be floating. Now see this example. Suppose this is a container which is containing some water. Now one body is placed over here. This is the body which is placed. Now how many forces is acting onto the body? Can you say me? See the diagram and say how many forces are acting on the body? There are two forces acting on the body. Which are these two forces? Number one is the weight of the body. So number one is the weight of the body, weight, that is your W, which is acting in the vertical downward direction, and number two is the upthrust. And which is acting in the upward direction. And therefore we can show now two forces acting on the body. One is weight of the body. This is the weight which is acting in the vertical downward direction, and another force which is your upthrust acting in the upward direction. The symbolic representation of the upthrust is FB. Remember, this is the symbolic representation of the upthrust. So when a body is immersed or submerged in a liquid, then two forces are acting onto the body. One is the weight of the body which is acting vertically downward direction, and number two is the thrust which is acting in vertically upward direction. Now in which case the body will float and in which case the body will sink? See over there, if number one, if FB will be greater than W, then what happened? In this situation what happened? when the upthrust acting on the body will be greater than the W or greater than the weight of the body. During this situation, the body will float. So here what is happening? The body will float. Now, if the upthrust acting on the body is equal to the weight of the body, then during the situation what happens? If suppose upthrust is equals to weight of the body, in this situation what happens? In this situation the body will float, but the body will float inside the liquid or inside the container. The body will not sink during this moment of time. So in these two cases we are seeing that the body will be floating. Here what is happening? In this case the body will be floating above the surface of the liquid, but in this situation the body will be floating inside the liquid. Now if this Fb or the buoyant force is less than W, then what happens? Suppose the thrust acting on the body will be less than that of the weight of the body. Then what happens? In this situation, the weight is more. So therefore, the net downward force will be becoming more. So the net downward force will be becoming how much? W into Fb. And due to this more net downward force, what happens? The body will sink. So remember, there are two conditions. When Fb or the upthrust is less than or is equal to W, then what happens? The body will float. And when the upthrust is less than W, then in this situation the body will sink. Now see here, the apparent weight in this situation, the apparent weight of the body will become 0. Therefore the body will be floating. Apparent weight, not the actual weight. Actual weight is W, but the apparent weight which is acting on the body will be 0. Due to that reason the body is floating. Over here the net downward force will be how much? How much will be the net downward force? This is, I have told you, W minus Fb. Now we can write thus W minus Fb is equals to the net force, that is the net downward force, isn't it? Now that implies W minus Fb is equals to, if mass is the m or m is the mass of the body and a is the acceleration of the body, then what I can write here? W minus Fb is equals to m into a, and that implies, now we can write here a is equals to W minus Fb divided by m. So the acceleration produced on the body when the body was moving in the downward direction or sinking is how much? W minus Fb upon m. So this all about the conditions when the body float and when the body sink. Let us discuss now the characteristic property of the upthrust. So what are the characteristic property of upthrust? Now see, what are the characteristic property of the upthrust? Number one, remember over here, if the volume of the submerged part of the body is more, then the upthrust acting on the body will be more. That means if the volume of the immersed surface of the body will be more in the liquid, then the upthrust acting will be more. That is number one characteristics. Now number two, the upthrust will be more if the density of the liquid or the density of the fluid will be more. Say for example, if you compare the upthrust of certain height in the river water to that of the same height in the sea water, in which case the upthrust will be more. Obviously the upthrust in the case of the sea water will be more. Why? Because due to presence of the salt in the sea water, the density of the sea water is more than that of the river water. So to the same height in the sea water, the upthrust exerted on a body will be more. That is number two. Number three, the upthrust always act in the upward direction, remember, and from the center of buoyancy. Suppose if I give the diagram, you will understand. This is the container which is containing the liquid. Suppose one body is floating inside the liquid here. This side is the weight, and then upthrust will act at this point. If this is the center of gravity of the body, or if this is the center of buoyancy of the body, then suppose this is the center of buoyancy, then from this point the upthrust will be acting on the body. And remember that upthrust always act in the upward direction and from the center of buoyancy of the body. And remember another thing, the property in which the liquid exerts the upthrust on a body is known as the buoyancy. Once again I repeat, the property in which a liquid exerts upthrust on an object is known as buoyancy. Alright, so what are the factors affecting the upthrust? So from these general characteristics, you may say me, what are the factors affecting the upthrust? So number one, obviously the upthrust acts on the volume of the immersed part of the body or the volume of the submerged part of the body, isn't it? If the volume of the immersed part of the body in a liquid is more, then the upthrust will be more. If the volume is more, then the upthrust will be also more. Now number two, it depends on the density of the liquid, isn't it? If the density of the liquid is more, then what happens? Upthrust will become more. So increasing density, then the upthrust also becomes more. Alright, so these are the factors affecting the upthrust. Now what is the unit of upthrust? Can you say me? Since upthrust is the force, therefore the SI unit of the force is what? Newton, and therefore the SI unit of upthrust will be Newton. That is in the SI system. You can write in the SI system, that is Newton, and the gravitational unit also would be there, that is your kgf. We can write also kgf. So these are the units of the upthrust. Now see, what is the mathematical expression of the upthrust? Remember students, the mathematical expression of upthrust Fb is equals to V into rho into G. This is the mathematical expression of the upthrust. So upthrust Fb is equal to V into rho into G. Here V stands for volume. V stands for volume. Volume of what? Volume of the submerged part of the body, and rho stands for density, and G stands for acceleration due to gravity. So once again I repeat, the expression of the upthrust is Fb is equals to V into rho into G. Here V stands for volume, rho stands for rho stands for density, and G stands for acceleration due to gravity. Next I will teach you Archimedes Principle. So now we will see what is Archimedes Principle. Now see here, suppose this is a container which is containing some liquid, and say one body is immersed in the liquid. When this body is immersed in the liquid, it is occupying some space, isn't it? And which was earlier occupied by the liquid. Now when the object or when the body is immersed in the liquid, then the volume of the liquid displaced is equal to the volume of the submerged part of the body, isn't it? Now how much liquid is displaced from here, or how much amount of liquid is displaced, that is equal to the volume of the submerged part of the body, that means the volume of this entire body, isn't it? If the volume of the body is say 10 ml, then 10 ml of water is displaced. if the volume of the body is 100 centimeter cube, then the 100 centimeter cube of water is displaced, isn't it? So therefore the volume of the submerged part of the body is equal to the volume of the liquid displaced. So therefore we may say the upthrust is equal to the weight of the liquid displaced by the submerged part of the body, and this is the Archimedes principle. So now what is Archimedes principle? It states that when a body is immersed in a liquid completely or partially, it experiences an upthrust which is equal to the weight of the liquid displaced by it. Okay, so write down. It states that when a body is immersed in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced. So this is your Archimedes principle. Once again I am saying you, it states that when a body is immersed in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced by the immersed part of the body or by the submerged part of the body. So this is Archimedes principle. Now let's see another topic I'll discuss with you, that is, if the density of the body becomes more than the density of the liquid, what happens? If the density of the body becomes less than the density of the body, then what happens? Whether the body will sink or the body will float. If the density of the body is equal to the density of the liquid, then what happens? Whether the body will sink or the body will float. Let's discuss this. Let us consider a body of mass m and volume b and having density say rho. Let us consider this is a body. The mass of the body is m, the volume of the body is v, and the density of the body is rho, which is immersed in a liquid. Say the density of the liquid is rho L. Now for liquid we are taking density is equals to rho L. That is the density of the liquid. So density of the body is rho, whereas the density of the liquid is rho L. Now the weight of the body is equals to, we know that the weight of the body is equal to the upthrust, isn't it? When the body is immersed in the liquid, the weight of the body is equal to the upthrust. From the Archimedes principle you have known, isn't it? So now let us find the weight of the body. The weight of the body, W is equals to, what do you know? M into G. Here G is the acceleration due to gravity and M is the mass of the body. Now that implies weight of the body W is equals to. Now how can you find the mass from the volume and the density? Because for the body the mass will be not required here. Only we should know the volume of the body and the density of the body. The volume of the body is given V and the density of the body is given rho. Now we will substitute M in the form of V and rho. Now from the formula we know that density is equals to, what do you know? Mass by volume. Therefore mass is equals to what? Volume into density. So in place of mass we will write over there volume into density. So V into rho into G. So this will become the weight of the body. Now let us find the upthrust of the on the body by the liquid. So the upthrust is equals to FB is equals to, that I told you, V into rho L, that is your density of the liquid, into G, acceleration due to gravity. Now in this situation the three cases may arise. Now what are these three cases? Number one, if the weight of the body becomes greater than Fv, then what happens? If suppose the weight of the body W is greater than Fv, so now we can write here W is what? V into rho into G. So we write here V into rho into G is equals to V into rho L into G. It is not is equal, this is greater than. Now V will be cancelled, volume will be same, G also will be cancelled. Therefore we will get here, that implies we will get here rho is greater than rho L. So in this situation the density of the body is becoming more than the density of the liquid. Before you have known that when the weight of the body becomes more than the weight of the upthrust, then what happens? The body will sink, isn't it? So in this situation the body will sink. When the weight of the body is becoming more than the upthrust, the body is sinking due to the net downward force. So how much net downward force is acting on the body? The net downward force acting on the body is W minus Fb. This is your net downward force acting on the body, and due to which the body will sink. So now we are getting that in this situation the density of the body is greater than the density of the liquid. So students, do remember here, if the density of an object will be more than the density of the liquid, then what happens? The object will sink in the liquid. Now let's see number 2. Number 2, if W is equals to Fb. W is equals to Fb means what? The weight of the body is equal to the upthrust or the buoyant force. In that situation, you know that the body is floating, isn't it? Or the body will float. So now let's see what is W. We know W is equals to V into rho into G is equals to V into rho L into G. That implies here we get rho is equals to rho L, which shows that the density of the body is equal to the density of the liquid. Means when the density of the body is equal to the density of the liquid, then the body will float. Now see number 3, if W is less than Fv, if the weight of the body is less than the upthrust, then what will get here? Here we are getting that when the weight of the body is less than the upthrust, then the body was also floating, isn't it? So see here, the weight of the body is here V into rho into G is equals to, that side we are getting V into rho L into G. So that is here less than sign. So V rho G less than V into rho L into G. That implies rho is less than rho L, isn't it? So it shows that the density of the body is less than the density of the liquid. Then the body will float in the liquid or in the water, isn't it? Now see the 3 cases I have discussed. Once again I am saying you, in this when the density of an object will be more than the density of the liquid, then the object will sink. Now, if the density of the object is less than the density of the liquid, then the object will float. Now, if the density of the object is equal to the density of the liquid, then the object will float. Okay, all right. Now, so there are three cases. Remember that how the object will sink and float from the density. If the density of the object is more, then the object will, here the object is sinking, and in this situation the object is floating. So float, here also it is floating. So when the density of the object is greater than the density of liquid, then it sinks, and when the density of the object is equal to the density of the liquid, it floats. When the density of the object is less than the density of liquid, then it floats. Now, if I give one example, you will understand it nicely. Suppose we will bring two bodies of the same mass. Say one body is made up of iron, another body is made up of cork. Now, when both the bodies are kept in water or immersed in water, then what happens? If both the body are left on the surface of water, you find that the iron will sink and the cork will float on the surface of the water. Why? What is the reason behind that? The reason behind that is the density of the iron is more than the density of the water, and due to this reason the iron is sinking in the water. Now, the density of the cork is less than that of the density of the water, and due to which the cork is floating on the surface of water. Due to this reason, a ship made up of iron is float in the water, whereas an iron needle is sinking in the water. What is the reason? When a ship is made up of iron, the average density of the iron ship is becoming more than the average density of the ship is becoming less than the density of the liquid, and due to this reason the iron ship is floating. But the average density of the iron needle is more than the density of the liquid or water, due to which the iron needle sink in the water. Okay, thank you.